Hi ladies and gentlemen, I did a video earlier that was on this particular worksheet, but I only did 1 through 6 and something happened to the rest of the video, so I'm going to redo it. Anyway, I did numbers 1 through 6, so you should be able to watch that video if you need to see numbers 1 through 6. I don't know if I got to 6, and I'm going to go ahead and do 6 at this point, which is second column and down a little ways. And by the way, guys, just a reminder, you really are allowed to fast forward as much or as little as you like. There we go. As much or as little as you like. Just go to whatever problems you're having issues with. So doing this particular problem, let's go ahead and get started very quickly. You are given f of x is equal to natural log of x, and g of x is equal to e to the x plus 1 power. Find f of g of 2 and find g of f of e. Okay. So what I want to do then is first I want to go on the inside, and inside of these parentheses I'm going to find g of 2 and f of e, and then I'll put that into where that given value should be. So let's start with g of 2. I'm going to start with g of 2. Let's see. Let's do that over here. G of 2 is equal to, and g of 2 is just e. If you plug in the x value of 2, you get 2 plus 1, e to the third, right? That's pretty easy. That one's not too bad, I don't think. Let's look at this. Great. Anyway, somebody's doing the lawn next door. Okay, so f to the e power, let's discover that one. Now, that may take us a second because I need to refresh your memory on what that means. Natural log of e. Remember, natural log is the same thing as, and I'll put that in red over here, natural log of any number is the same thing as log base e of any number. Okay? So really, and if you think about it, anytime you've got a base of a log and it matches whatever you have here, that's going to be equal to 1. And if you don't remember that or why that is, grab real quick. Sorry, I needed that up here to start with. But let me bring this up. So if you have something like log base e of x equals y. Okay, I'm not using natural log. I just want to show you how we do this. Write that in exponential form. So I would start with the base, and that would be e raised to the, go to the other side of the equal sign, e to the y equals back to the other side, x. So I kind of play tennis. Start with the base and go across the equal sign and back. So I want to change, if I looked at natural log of e up here, natural log of e is like log base e, right? Of e is going to be equal to some value. Write that in exponential form. So e to the x equals e. Well, what does x have to be? X has to be 1. So what that means is that the natural log of e is equal to 1. Okay, and that's one you will know. If you have forgotten it, we'll use it a lot. So you will know that one. All right. So, all right, so we found f of e, we found g of 2. So let's go ahead and plug these pieces into our puzzle here. So we have f of e to the third, because that's g of 2. And then we've got minus g of, well, that's g of 1, because f of e is 1. All right. Now f of e to the third, well, again, I got to kind of think about that. I got to put that into the, I got to put e to the third into the x value for f of x. I'm going to do that again on my little whiteboard here. So if I've got f of e to the third, replace that natural log with e to the third. And again, this is another log kind of property you need to remember. Remember when you have an exponent with your logs, you can bring it to the front. So that's the same thing as 3 natural log of e. And remember, natural log of e is 1, so that's equal to 3. So f of e to the third is just going to be 3. Get this right. 3. And then g of 1, well, I'm hoping that's really easy. G of 1, plug in a 1, you get e to the second power. Now hopefully we can see that somewhere out there. Hopefully we can find it. Let's see. I think it's on the other side. Second page, that is. Yep. It is on the other side, first column. This would be considered number 7. Okay, I'm kind of keeping myself in place. Yep. All right, so now let's look at this particular problem. Oops, you can't see that very well. I apologize. There we go. We'll look at this one now. In this particular problem, again, we are given a function, and we're asked to find f of 3 plus h and f of 3 over h. So anywhere I see an x value, I simply will plug in whatever I've got in those parentheses. So I've got 2 sets of parentheses. I've got 3 plus h, and I've got just plain old 3. We'll start out by finding f of 3 plus h. And again, I'm going to bring up my whiteboard here. Okay. So f of 3 plus h. And I want you to think about that. Again, look, here's where f of x is. So everywhere I see an x, I plug in 3 plus h. So that means I have 3 plus h squared plus 5. I just plugged in the x value of 3 plus h. Now I do need to kind of complete this. I am going to go ahead and multiply, and hopefully you remember the sum of a binomial squared. Hope you do. It gives you a perfect square trinomial. If you don't, I'll give you a quick refresher here in just a second. Those of you who get it, you can just fly through this. But again, gosh, the different colors are not showing up on my screen. I'm so sorry. But if you had 3 plus h squared, that's the same thing as 3 plus h times 3 plus h. You can distribute and add like terms if you want, or you can remember the perfect square trinomial, which is first term squared, the 2 terms multiplied together and doubled, so 3h times 2, 6h, and last term squared. It's a lot easier if you can remember that. We use it a lot, so I would highly recommend it. All right, so let's complete this f of 3 plus h. That gives us, and I'm going to go ahead and put this in descending order, so h squared plus 6h plus 14. That's going to give us the f of 3 plus h. All right, let's go ahead and also find out, I guess we need to find out f of 3 also. So I'll come over on my whiteboard just a little bit here. F of 3, all I need to do again, where I see x, I plug in a 3. That's 3 squared plus 5, and hopefully you see that very quickly as 9 plus 5 or 14. All right, so let's plug in what we know about f of 3 plus h and f of 3. We know f of 3 plus h was h squared plus 6h plus 14. That's going to give me the f of 3 plus h. And then it's minus f of 3. So minus 14, because that's what f of 3 is, all over h. I don't need my whiteboard. Okay, now there's no answer on here that looks like that. We kind of have to play with this a little. You notice the 14s will cancel. And then you notice that in the numerator we have we have h in both of the terms there. So let's go ahead and factor an h out and make that h times h plus 6 over h. And you can see very quickly you can cancel out your h's. You are left with h plus 6, which I think is the same thing as 6 plus h, which is down at the bottom on the right. Next question asks you to find if the perimeter of a rectangle is 68 and the width is 10, find the length of the diagonal. Every time I see something like this, I will make a picture if I can. So they said that the perimeter is 68 and they said the width is 10. And I don't know what the other side is. I guess I'll just call it x, but I am looking for the diagonal. Okay, that's what I'm looking for. Okay, well that's not as bad as I thought, because truthfully it's a rectangle, so I do know that the other side is 10 for the width, and I know down here at the bottom that's x, and this is a right angle because it's a rectangle. So what else can I find out? Well, since the perimeter is 68, I could say 2 times x plus 2 times 10, or 20, should be equal to 68. So then you can solve for x, subtract 20, divide by 2, and I'm going to do that really quick. So subtract 20, you get 48, divide by 2, you should get 24. Okay. All right, so I can make a 24 right here. Now, I don't think it'd be hard to find the diagonal if you think about the Pythagorean theorem of this right triangle here. So I can look at this as 10 squared plus 24 squared equals d squared. So 100 plus 576 is d squared. 676 is d squared, which means that d is 26. Okay, we found it as 26. I hope we have that. Otherwise, I made a silly mistake, and we do. Same side, up on the same column even. Oops, I forgot to put the numbers down, didn't I? This was number 8, so this one up here would be number 9. Make sure from my key that I am going in the right direction. I've made some silly mistakes in the past. I've got to be careful. All right, this one says find x squared minus y squared. But you're told that x plus y is 7, x minus y is 3. A lot of you can figure out what x and y are just by looking at that. You've just got that mathematical head. Some of you are like, I'm not sure about that. You can solve for x and solve for y either by using these two equations using elimination or substitution. I find elimination to be the easiest for this one. Either way would be fine. So in other words, I'm going to take the x plus y equals 7, and I'm going to combine it with x minus y equals 3. If I add those two together, all right, then you see that y's cancel. I'm left with 2x equals 10. Therefore, x equal 5. Okay? Found x equal 5. And honestly, come up here to this. If x is 5, what does y have to be? Well, so y is equal to 2. Okay? All right, so we found x. We found y. Plug it back in up here. And let's find out, what is x squared minus y squared? So 5 squared minus 2 squared is 25 minus 4, 21. Now you can pause it at any time. I know I'm going a little fast. I'm not slowing down to let you think. You may have to pause because I don't want this video to be super long if possible. All right, so my answer is 21. Let's see if we can find that somewhere. It must be on the other page. It's on the first column of the front page. Okay, what number was that again? That was number 9. That makes this number 10. Okay. Looking at my key, making sure I'm not going to mess you guys up. Good. I'm doing good. All right, so let's do this one. This one seems to throw a lot of people off. I've had a lot of questions about this specific question. It says f of x is equal to the inverse of g of x. They give you g of x. Question is, what is f of 5? Recognize that we're really finding the inverse of g of 5. That's really what we're doing. And refreshing your memories. I do want to refresh your memories. So if I've got a function, and I'm just going to call it, we'll call it g. We'll go ahead and call it g of x. I don't know what, let's not call it g of x because I'm not going to figure out what that is. Let's call it h of x. And let's say we have a point, -2, +3. Then the inverse function of h of x is going to have a point that's not -2, 3 necessarily, but 3, -2. Okay? So that's all it is you're flipping your x and y. Remember that? I hope you do. So if this is saying the x value for the inverse is 5, that means the y value for the original function is 5. Okay? And look at that. If the inverse x value is 3 on this one, then the y value of the original is 3. So all I need to do over here, since f is the inverse of g, is replace g of x with the 5. So I'm going to replace it with 5, making that 5 equals 2x, over x minus 1. I did not mean to put that there. All right, we need to solve for x. That means I need to get the x out of the denominator. The only way to do that is to go ahead and multiply both sides by x minus 1. Do that over here. Hope you can see this. It's kind of hard to see, but that is what I'm doing. So we will end up with, I'm going to distribute the 5. This looks horrible. I hope this will be okay for you guys. If not, let me know. But we're going to distribute 5 times x and 5 times 1, making that 5x minus 5 is equal to, and we see that the x minus 1 cancels. We're left with 2x. Now it gets to be super duper easy, right? Subtract the 2x, add the 5. So subtract the 2x, add the 5, divide by 3. All right, so we're looking for an answer of 5 over 3. I hope I didn't mess up my signs. We'll find out. Turning this over. That's what I like about circuits. You kind of self-check yourself. All right, this was number 10. I did find that over here on the other side, first column. Make that one a number 11. Yep, going in the right direction. Okay. Oh, we got another one that has natural log in it. I am so glad because I think we need to get lots of extra review for natural log. Do you remember, it says solve for x, and our x value is within our logarithms, our natural log, should I say, but it's a logarithm, base e. So it's within our logarithms. So in order to get the x out, we're going to eventually have to put it into exponential form, probably, which means I need to combine this into a single log. So combining single log into a single log, if you've got 2 logs separated by subtraction, then we're just going to end up using the quotient rule. I don't know if you remember that. You may not remember the name, but you should remember what happens, or at least this will refresh your memory for it. So we will combine these two together, and we end up with natural log of x, the first one, over quotient rule, x plus 2. So it becomes one single log on the left side, and that's equal to 1. And now that it's a single log, I can change this into an exponential form. Remember, ln is just natural log base e. So we will make this e raised to the first power, e raised to the first power. Remember, play tennis here. Sorry, big old hand. E raised to the first and then come back. So we're kind of going to one side of the equal sign and then the other. So e to the first equals x over x plus 2. We're going to solve this similarly compared to what we did on the last problem. What I'm going to do is a little work on my whiteboard here. I'm going to multiply both sides by x plus 2. Okay. And then we see those cancel out. We can distribute e over here. We'll end up with ex plus 2e. Because it's just e to the first. I don't need to put e to the first there. And that's equal to x. Now remember, when you've got more than one term that has the variable in it you just want to get all those terms with that variable on one side and everything without the variable on the other. So let's subtract x so that we have ex minus x. And then let's take this 2e and bring it to the other side. So we're going to subtract 2e. Okay. Slow down if you need to. All right, so on this left side, we've got two terms with x in it. That means I can factor out the x. Now this gets super easy. Factor out the x so that you have x times e minus 1. Just factor it out in x, equal to negative 2e. And now it's super duper. You just divide by e minus 1. Okay. And I end up with, well, you can see it. I don't need to rewrite it. All right, let's see if we can find negative 2e over e minus 1. Oh, I found it. Kind of. Let's look at this. Okay. See how similar that is to our answer? Oops. Well, no, I guess you can't see it. There we go. You see how similar that is? It's not the same though, is it? This is what circuits are all about. I want you to be able to manipulate your answers. Doesn't mean you've got it wrong if you don't find it. It might mean that you need to manipulate it. This is important, especially when you start doing multiple choice, which we have a lot of in calculus. So I can look at this, and instead of having the negative up in the numerator, I can plop it down to the denominator. So in other words, I would have 2e over negative, and I just distribute it through the entire denominator, remember? So I just took the negative from the numerator, plopped it down here, and you can see you get negative e plus 1. So I could definitely write that as 2e over 1 minus e. And that does look just like this. Oops. All right, so definitely is going to be this is our answer. Okay, that's number 12. Okay. All right, so now this one, I love this one. I think this is such a cool one to do because this has to do with what you did last year in pre-cal and the year before in Algebra 2 Trig when you were talking about finding horizontal asymptotes. Because it says, as x grows infinitely large, the value of h of x approaches what number? In other words, it's going to get close to some number and then level out. It's not going to ever get there. That means we've got an asymptote. It's a horizontal one because we're talking about what h of x is approaching. That's great. There were 3 rules that you might have memorized for figuring out what that asymptote is. But the truth of the matter is, I don't think you need to memorize it. I think you need to understand the concept, and you'll never, ever have to worry about memorizing it because you'll get it. You'll get the concept. So it says, as x grows infinitely large, the value of h of x equals whatever, approaches what number. What that's saying is, we can take that x and just make it really big. Let's just make an example up. Let's use a big number. Now, your idea of a big number may be different than mine. I'm just going to use something fairly easy and see if I can figure it out from there. Let's make it 10,000. Let's make x equal to 10,000. Well, if I find your h of 10,000, I would get 2 times 10,000, which is 20,000, right? I mean, that's pretty easy. 5 times 10,000 would give me 50,000 plus 8, so 50,008. Okay, guys, can you see how this 8 really is insignificant? What is this approximately? What is 20,000 over 50,008 approximately? You can see, you can cancel that piece out and you're left with 2 over 5. Okay? We'll talk deeper on this when we get to some of our limits. It's kind of exciting. I love it. So, as x grows really big, h of x is approaching 2 over 5. All right, so let's find 2 over 5. Where is, there it is, down at the bottom. Same page. So this is number 13. Okay. This one's fun too. I know my definition may be different than yours, but it's fun. So the expression 3x squared is used to calculate the slope of any given point on a graph of the function g of x equals x cubed minus 1. Write the equation of a line tangent to g of x at its x-intercept. I always look at the end. What are they asking in the first place? Write the equation of the line tangent to g of x at its x-intercept. So the big thing is, I got to write an equation, right? Of a line. So what I need is I need to remember a couple of things. I need to remember the equation of a line looks something like this. Y minus y sub 1 equals m times x minus x sub 1. And remember, x sub 1, y sub 1 is the point that the line is going through, and m is just the slope. And truthfully, that is all I need to find. I need to find the point, a point. It doesn't matter what point it is, just a point, and the slope. Now, specifically, they gave us a point. They said write the equation of the line to g of x at its x-intercept. That means this tangent line is at a given point. I'm sitting here thinking, I'm wondering if you remember what a tangent line is. All of a sudden, that just hits me. Do you remember what a tangent line is? X cubed minus 1, we'll call this g of x, could look something like that. It could. And our x-intercept could be right there. A line tangent to g of x will be, it just follows along the curve. It only touches a curve at that point, basically. So a tangent line up here would look, mine's terrible, but it would just touch the curve at one point, kind of skim it. So that's what we're looking for. We're trying to find the slope of this line. First thing we want to do, though, is find that point. So it says it's tangent at the x-intercept. What do we know about an x-intercept? We know the y value is 0. If it crosses the x-axis, the y value must be 0. So it could look like this. Let me put it in black. Could look like this. That could be what our graph looks like. It has to cross the x-axis, the x-intercept, the y value would be 0. We just need to know what the x value is. That's not hard, because we know what g of x is equal to. We know that g of x is equal to x cubed minus 1. So since I know that the y value is 0, pretty sure we can figure out what the x value would be. So add 1, cube root it, and you come up with x equals 1. So our x-intercept is where x is equal to 1. All right, so we found the point. The point is x is 1, y is 0. So we can plug that in right here, right? I'm going to do that up here. It means I've got y minus, instead of y sub 1, I'll put what the y, oops, you can't see what I'm pointing to. I'm going to put in the y value, 0. I don't know the slope yet, so I'm going to leave that alone. And then it's x minus x sub 1, so x minus 1. Now, what do we know about the slope? They told us something in here. They said the expression 3x squared is used to calculate the slope at any point on the graph. All right, so all I need to do for the slope is to simply, I know the slope is going to be equal to 3 times x squared. What is the x value? 1. So hopefully you can see the slope is 3. And there you go. That's the hardest part. I'm pretty sure you can simplify this, distribute your 3 through, and you should end up with y equals 3x minus 3. Let's go find it. Let's see. I think it is on the other side. Yep, this is number 14. Okay, so for number 14, I am doing good, okay. I don't want to make a silly mistake somewhere. All right, we're evaluating g of x. Okay, it says g of x is 5 sine of x plus cosine of 2x for x equal pi over 2. This is unit circle territory, guys. If you don't have your unit circle, you don't remember your unit circle, you're going to have to print it out, get it off the internet, I don't care. Print it out and use it until it's in your head. You've got to get that down, especially in BC. So we'll use it. I don't expect you to know everything right now. Let me move my head somewhere else here. There we go. Okay, so evaluating this, let's go ahead and plug in the x value. So that means g of pi over 2 is equal to 5 times sine of pi over 2 and plus cosine of 2 times pi over 2. So hopefully you remember that with the unit circle. The x values of your unit circle are your cosines. Your y values are your sines. So that'll help you because this is 5 times sine of pi over 2. So you remember this is 0 pi, and then up here is pi over 2, and over here is pi. This was 3 pi over 2, and if you go all the way around, you end up with a 2 pi. So you could call this 0 pi or 2 pi, it doesn't matter. We only use radians in calculus, so at least you don't have to figure out, am I doing degrees, am I doing radians? It's always radian measurement. All right, so sine of pi over 2, well, here's the angle pi over 2. I think that would definitely represent the angle pi over 2. That y value, we know the x value is 0, the y value for a unit circle is 1. So the sine of pi over 2 is 1. So that means we've got 5 times 1. All right. Now we've got plus, and this is cosine of pi over 2 times 2. I hope you can see that as cosine of pi. Okay. And if we look down at our unit circle, pi right here, remember cosine is our x value. So what is the x value over here for the unit circle? It's going to be -1. That point is -1, 0. So the x value is -1. Cosine is -1 then. So that means we've got 5 plus a -1, which gives you 4. Alrighty then. Let's find our answer. So we look and we find it. It's on that same page, but it's up on the first column. Let's see, what was that one 14, so this is 15. This one says simplify this expression, then evaluate the results for x equal -5. Y'all, this is a tough one, but in BC Calculus, you do have to know how to factor the sum of two cubes. Let me refresh your memory on this. You may want to write this down on a formula sheet. A cubed plus b cubed factors as a plus b times a squared minus ab plus b squared. This is just simply, all that is just a formula you need to know. And this is another formula you may want to know. The difference of two cubes, almost exactly the same. A minus b, a squared plus ab plus b squared. I always look at it as there's only one, when you factor it, there's only one negative sign throughout for either one of these factors. So you minus sign here, but no other there, and there's a minus sign in that second factor, but none on the other one. So it kind of keeps me straight a little bit. Anyway, this is the sum of two cubes. X cubed plus 125 could be written as x cubed plus 5 cubed. So we can factor that as x plus 5 times, and it would be x squared minus a times b plus b squared, or 5 squared, which is 25. So we factored this numerator. I'm going to put it over the denominator. And hopefully you can see a quick cancellation happening. It then says evaluate what you get for x equal -5. If we would have plugged in -5 to start with, we would have ended up with 0 over 0. And that doesn't tell us anything. But when you factor and cancel and you plug back in -5, you get a different answer. And I think you can plug in a -5 for your x. I'm not going to go through the basic math. You should get 75. Okay, so let's find a 75. And there it is. Whoops, what number was that? 15. So this is 16. Okay, this one's a little bit of a complex one. It looks simple, and it kind of is, but this brings up another fact. And we're going to have a trig day. We'll have one very soon. I think we're going to be having it extremely soon. Because we've got to remember some identities too. You don't have to remember every identity under the sun for trig, but we do have to remember the double identities. I don't know if you remember those. It's okay if you don't. I'm going to refresh your memory because they tell you what sine of A is, and they ask you to find sine of 2A. Be aware though that A falls between pi and pi over 2. So I do want to look at that on the unit circle quickly. We're going to evaluate this. So on the unit circle, what quadrant is from pi over 2 to pi? Because that's what this is, pi over 2 to pi. So hopefully you remember that would be, this is our pi over 2, here is our pi. So that tells me that the quadrant we're looking at is right here. That's going to be important in just a little bit. We'll come back to that in a minute. All right, so find sine of 2A. Well, I don't know what A is. I know that sine of A is equal to 5 over 3. So what I could do is I could remember that lovely trig identity that sine of 2A is equal to 2 sine of A cosine of A. It's a nice one to remember. And then you can simply plug in what A is. Well, let's see. That gives me 2 sine. Oops, I already said what that was. Oh, I don't have an eraser. Cuss word. Okay, so 2 times 3 over 5. There's sine of A. Oh, wait. I don't know what cosine of A is. I'm going to have to take a second to figure this piece out. So what I'll have to do is I'll have to say, well, if I know what cosine is, I know cosine is 3 over 5, I could think about right triangles, and that is where our sine and cosine come from. I could take a nice little right triangle here. If my angle here is A, then the sine of A, if its sine of A is 3 over 5, remember sine is just opposite over hypotenuse, 3 over 5. And cosine, if you remember, is adjacent. That would be this side over the hypotenuse. I just need to know the adjacent side, which is, well, if you need to use a Pythagorean theorem, you can. 3 squared plus x squared equals 5 squared, and figure it out. Or you remember that basic, this is a Pythagorean triple that a lot of people use a lot of times. So this side is 4. If you need to use a Pythagorean theorem to find it, that's fine. I'm just not going to do it. All right, so cosine of A would then be 4 over 5. Look at that. That's not so bad. So then we multiply across 2 times 3 times 4. Let me put it in the red so it doesn't get mixed up. 2 times 3 times 4, 24 times 2, or 12 times 2, which is 24. And then denominator 5 times 5, 25. But you know, you're going to find that there's no positive 24 over 25 on either side, but you'll see a negative. And the negative is the correct one. And that's where we have to remember. Oh yeah. Our A value, our angle value, falls between pi over 2 and pi. So that means it's in this quadrant, which means my sine will always be positive, but my, oops, I just did that wrong. Way to confuse my students. My cosine will be negative and my sine will be positive. The x values are negative in this quadrant. The y values are positive. So that's the cosine and sine. So that means my cosine here should be a negative, which means this is negative 24 over 25. And again, I like these circuits because it keeps you honest. When you turn over the paper and you see negative 24 over 25 and how close it is to your answer, if you didn't think about the quadrants, that would keep you straight. All right, let's go to number 17. Number 17 says the graphs of g of x equal natural log of x plus 3 and f of x equals all that stuff have the same vertical asymptote. What is it? There's 2 ways to find it. If they both have the same vertical asymptote, unless I think one of them has 2 vertical asymptotes, they don't. I know that, for example, f of x, since it's a fraction, I know, or it has a denominator, that denominator is not, it can't be 0. X plus 3 cannot be 0. And remember, vertical asymptotes have to do with the domain, what our x values cannot be. That's what our x values cannot be. That's the limitation to our domain. So I always look for where my x values would not work in a problem to find our vertical asymptotes. The denominator can't be equal to 0. So x plus 3 cannot be 0. That means x cannot be equal to negative 3. That tells me that I have a vertical asymptote at x equal negative 3. Now, why is that the same over here for our natural log of x plus 3? Quick little refresher here too. If you graph the natural log, okay, if you graph the natural log here, you would, oh goodness, excuse me, I don't have COVID. Okay. It kind of levels out as you go up. It looks like it's leveling out. It just goes up slower and slower, but it continues to inch up and up and up forever and ever. And this goes down forever and ever, but it never touches that y-axis. So the vertical asymptote falls right there at x equal 0. And remember, this piece after a log, that x plus 3 must be greater than 0. So x has to be greater than -3. I certainly didn't graph this one right. It needs to be shifted a little bit over this direction. But I just wanted to show you a basic natural log. Maybe I need to put that y equal natural log of x. Okay. All right, so I'm looking for x equal -3. That's my vertical asymptote. Here it is over on the other side. So this will be number 18. Hey, this kind of this goes into what I just talked about. Remember? Your natural log of what you have here can never be, it has to be greater than 0. Not greater than or equal to, but greater than 0. So when it says state the domain, I simply have to take x minus 2 and make it greater than 0. So x is now greater than 2. There is my domain. That was quick and easy, right? That was number 18. So this is number 19. We're getting so close to being done, I can't see straight, and I'm so excited. All right. So let's find out what we got going on here. Goodness. I swear I don't have COVID. All right. So this is, you can plug this in the calculator and get this, but remember what this stated at the very top, no calculator. So I don't want you to use one. I really don't. I want you to be able to do it without one. Can you rewrite these terms in radical form? If you don't know these answers, rewrite it in radical form. That means that first one here, got the 81, that denominator for the exponent tells me that's my index. And so it's a 4th root of 81 to the 3rd power. Next one would be, got the 8, and that's going to be a cube root to the 2nd power plus 125. What root is that? Cube? And it's not raised to any power. I mean, I could put to the 1st, but I don't need to. So the 4th root of 81, what number do you multiply together to itself 4 times and get 81? That'd be 3 times 3 times 3 times 3. 9 times 9, right? So the 4th root of 81 is 3 cubed, or 3, and then we cube it. The cube root of 8, hopefully you know that's 2 times 2 times 2, would give me 8. So the cube root of 8 is 2, so 2 squared. And then the cube root of 125, you probably remember, 5. Because 5 times 5 times 5 is 125. And we simply add this together. So you have 27 plus 4 plus 5, and that gives you a 36. So 36 is, oh, just boop, boop, right there. So 36 right here. So this will be number 20. I'm going to do a different color so it doesn't get all mixed together. All right. So this is 20. It says state the range. And again, range has to do with, is there an asymptote? Just like domain has to do with, is there a vertical asymptote? Range has to do with, is there a horizontal asymptote? And remember back when we did this one? This one? It's the same process. And especially in this one, it works out. Because the degree in the numerator is a first degree, the degree in the denominator is a first degree. And so that just means that I have a horizontal asymptote where I have 2 over 1. So in other words, if I graphed this, there'd be a horizontal asymptote where y equals 2 over 1. Okay? So what that tells me is that I can't have, y cannot be equal to 2. So that means I can go from negative infinity all the way to 2, union from 2 to infinity. I'm kind of going fast because my computer's getting ready to die. Or storage is getting ready to go. I got to figure out what's going on. So this is answer 20. Let's find answer 21. Other side, I think. Wasn't it? Or did I miss it? It's because I'm in a hurry now. I know what's going on here. Where did it go? Am I blind? Say, Miss Summers, you certainly are. There it is. Duh, I am blind. So this would be number, what did I say, 21? Yeah. All right. This has to do, we've got 2 logs, and truthfully, we want to make them a single log. It's very easy when you see it as a single log. If I bring it as a single log, since the logs are being added together, sorry, it should not pop up. We just multiply 25 and 4 to get 100. Write that in exponential form and tell me what x is. I mean, that's pretty easy, right? 10 to the x equals 100. You know x has to be 2. All right, so let's go find 2. Must be on the other side. Must be the last one over here. No, yeah, it is. Good. Number 22. This tells you have a semicircle, and it's in quadrants 3 and 4. Find the domain. If you really know how to graph real well, you could easily graph this semicircle, and you could easily see the domain. But if you don't, that's okay. Look at it this way. All right, look at it this way. What's underneath the radical, or in what we call the radicand, that number has to be greater than 0, doesn't it? Greater than or equal to. So you could take 4 minus x squared and make it greater than 0. Solve for x. Okay, so I don't care. Let's make that x squared is then less than 4. All I did was, you can bring that x squared over here and leave the 4 there, or you can bring the 4 over there and divide by -1. But what you end up with is x is, it's kind of weird. This is kind of strange. But x is greater than -2 and x is less than +2. And think about it. Put a +2 under, put it like an x value that's greater than this +2. If I put a 3 in, I'd get 4 minus 9, and that'd give me a negative. That's not good. So this makes sense. And then if I had if I had a number that was less than -2, something over here,